Hello Nonian colleagues, this is a short video to help you assemble your new needle valve. I have the actuator of the needle valve disassembled here to show you the inner workings. The central part is this set of bellows. It allows you to transmit longitudinal movement into the cryostat without breaking the seal. The inner volume of the bellows is connected to the VTI circuit and so filled with pure helium gas, and the outside of the bellows is exposed to the room atmosphere. So the seal is obtained by firmly clamping the outer edge of this flange to a metal O-ring in the fitting on your system. The bellows will allow you to transmit about maybe a few millimeters of movement, and it is quite strong in the longitudinal direction, but of course it will not tolerate any twist. So if by accident the central part of the bellows is twisted with respect to the bottom flange, the bellows will get broken. This is the outer body which contains the bellows. It is fitted with this rotary knob with a fine pitch thread to allow you accurate position of the needle. The bellows are fitted inside and connected to the knob with a small bolt, and when the bolt is fully done up, there is still freedom for the knob to rotate without turning the bellows. So when this mechanism operates, the bellows rotate, the knob rotates, and the bellows, the central part of the bellows, moves in and out without twist. This mechanism is attached to a component fitted to the top of your cryostat, component which looks very much like this and has a metal O-ring in this groove. Before fitting, you will need to make sure that the knob is at its top position, so the bellows, the edge end of the bellows is not visible outside the housing. This will make sure that the bellows are not overly compressed when the mechanism is attached to the system. The seal is made by pressing this flange to the metal O-ring, and everything is held together by this fixing nut, like that. But before you attach the mechanism, of course you will need to insert your new needle valve tube. Here it is. This tube is not welded to the mechanism, so you will be able to first insert it into the cryostat through the hole in your VSM table, and then bring the mechanism from the side and couple them together. You need to carefully insert the tube until it hits the bottom of the system, until the needle engages with the seat of the needle valve. To mark the correct position of the tube, we use this nut. And the only adjustment you need to make is to make sure that when the tube is fully inserted and touches the bottom of the system. The distance between the top edge of this component and the top of the nut is approximately 3 millimeters. It can be 3.5 or 4 or 2.5. This distance can be quite easily measured using vernier calipers. So the distance between the top edge of the fitting on your cryostat and the top of the nut has to be 3 millimeters. You will obtain this by trial and error. So you can put the nut somewhere at first, drop the tube, measure the distance, and if the position of the nut needs to be changed, you change it slightly and remeasure until you obtain the correct position. After that, you take the tube out by maybe 5 or 10 centimeters so that you can hold it at the bottom. Get the actuator mechanism and you couple them together like so. You will see that the central part of the bellows has these flats. It's rather unfortunate that the flats are the distance between flats is slightly larger than 7 millimeters. It is an imperial measurement. But if you have a small adjustable spanner, you can hold the bellows here to make sure that when everything is screwed together, the bellows do not get twisted. You do not need a very hard fitting here. Finger tight is more than enough. So when this is done, insert the tube back into the system. Because of that 3 millimeter distance that we measured, now the needle is floating a little bit above the seat, and this corresponds to the position of the knob at the top of the mechanism. So we adjusted correctly. The needle is lifted and the knob is at the top of its travel. For this reason, when we attach this nut and make it tight using a 30 millimeter spanner, nothing is going to be jammed. The mechanism is at the top of its position and the needle is floating above the needle valve seat. The final part of the assembly is fitting this vernier knob. It just pushes over and there is a grub screw here which fits it to the brass knob. So this should complete the assembly. Please make sure that this nut is fully tightened so that the housing of the mechanism is hard pressed to the metal O-ring. This will prevent air leaks into the system. Gently rotate the knob and check that the needle can move up and down. You will feel very little resistance to movement at first until the needle engages with the seat. When this happens, do not apply excessive force. The whole idea of this mechanism is that it should use with reasonable force. So if there is unusual resistance to movement, it must mean that something is wrong. Everything should work with reasonably little force. So I hope this is all clear. This is exactly the component I'm going to send to you. What I haven't said, I want to draw your attention to the fact that the tube of the needle valve is straight. We made special effort to keep it straight, so please do not bend it. Everything works much better when this tube is straight. In this case, it goes inside the system without any mechanical resistance. Before actually inserting the tube inside, wipe its surface using acetone. This will remove any finger grease or dirt. Of course, the bottom end of this tube will get cold, and any dirt or moisture or grease may cause it to freeze and jam. So I hope this is all clear enough, and I hope that you will be able to assemble everything without too much trouble. If I left anything out, please do not hesitate to email me and ask. Good luck!